I would like to introduce him a little bit, and since I know him quite a long time, and just want to say actually, I know Bo for 10 years. This year, actually 10 years, because of I'm the second employee he hired since he started the center. So when we discuss about the topic, the keynote speakers, and we can easily find like, lots of excellent keynote speakers. And then we talk, because Bo can talk about from IoTs, cloud, AI, big data, digital twins, whatsoever, if you want to ask him to present. And however, actually, the first year for Energy Informatics Academy conference, we try to call for papers which address a very important topic is education in the energy informatics field. And I think all of us actually is either from the energy, have a background for energy, no matter about electrical engineering or mechanical engineering, whatsoever, and we're from energy, and we use these informatics digitalizations in our research. Or is another round come from computer science, software engineering, data science, then we applied in the energy field. However, actually, you can see we are really lack of some really fundamental focus and design in the energy informatics field from this education perspective. So that is the reason why, and also both for 20 years, I think he's already working in the academic for more than 20 years, but for 20 years, he has been involved and designed for 5 educational programs. So this time, he's going to introduce the latest education program he have been lead and designed.
Thank you, Grace. Yeah, I've been doing quite a number of educational programs over the years. Some I have been part of, make revisions, contributing to part of them, and some of them I have designed from, greenfield design from bottom up. So I will try to share some of the background for my latest work on a master program in Energy Informatics, an international master program that we hope to launch in 2025. It, of course, depends on whether we get the approval from the ministry. And I will try to take you on the journey and background for actually designing this. So if we go back to what might somehow be the beginning for when the design of an education start to emerge is actually when there is a challenge, when there is a societal challenge that have to be solved. And it's actually quite early, already back in 87, there came out this report that some of you might know, the Brundtland report, that, start to put up the warning that something is wrong. We are going to face global warming due to our overuse of fossil fuel. People ignored it for quite some years until fast forward to 2015, where we had the Paris Agreement, where people finally, or the government finally agreed that we would do something about it, or at least it's the intention, to see if we can try to keep the temperature increase well below 2 degrees. Now, as you can see, the CO2 level have been going quite up over the last year. I remember when I started to work with greenhouses back in 2007, that the ppm was 380. Now the ppm is 400. So there have been quite an increase in the CO2 level in the atmosphere. And as we also have noticed over the past years, also as Louis showed some really, terrible examples of what is actually happening here in Brazil. This year, I just took some pictures here from the last years in the Philippines and Australia, Italy here, and basically also just the heating in all of Europe. So change is happening. And this, of course, called for a totally transformation of our energy system towards renewable energy. And this basically also this transformation that is one of the reasons why we need to look into the digitalization of the green transition. But of course, there's a question, why? Why do we need digitalization in the green transition, right? I mean, there need to be a reason. So when we start to look at the reason, we can go back and see how our electricity grid looked before we started to have a lot of renewables. This is a very good old conventional grid where we just generate what we need based on the demand. So supply follows the demand. That have of course changed as we know, that we start to actually to have a lot of distributed renewable energy resources at the consumption side. We saw here from the Sustainable Campus project with all the PVs on site. We also have seen in Denmark a lot of distribution of wind turbines all over the country, and now also PVs. So it all changes. So it's not really the big power plants anymore that supply all of our electricity. We also have a lot of distributed generation. And this leads to a lot of unbalance. As Henrik also was talking about, we need to have flexibility suddenly in order to be able to match the fluctuating renewable energy production. What you see, the graph you see here is a graph for the wind turbine production in Denmark over a whole year. So you can see a large fluctuation starting in January with a large high production, large fluctuation. Then we hit the summer where we have less wind, and then finally we go into the autumn and winter again. So it's actually all of this fluctuation that we need to be able to balance with flexibility. So in order to do so, we are looking into having this, I call it the energy infrastructure, built on top of the energy infrastructure. So it's actually here that the whole digitalization comes into play in order to help us to integrate all of the renewable production on the consumption side, and also from big wind turbine parks here on the large generation side. So in building this infrastructure, we have been through a number of phases in the digitalization. We have been through the digitization of a lot of analog assets, just like your invoicing for your electricity consumption, doing simple metering and so on. We have also seen the digitalization of the services, like now you can go online and you can see how much electricity you have been using and all these apps that starts to come. And finally, we will have to go through the digital transformation, that is the full digitalization of the whole ecosystems, where every aspect plays together from the consumption side and production side. And this is actually also, this whole digitalization, digital transformation of the ecosystem is also what is necessary in order to get the full benefit of flexibility. So this is back to the background, and that leads forward to the field of energy informatics. The first book on energy informatics came out here in 2011, based on papers from 2009 and 2010 by Richard Watson, who actually wrote this book based on a number of case studies he has made. And when I read his book, I realized, oh, this is what you're doing. I mean, so it's basically also the background for founding the Center for SDU Energy Informatics based on this book. So very short, what energy informatics is, it actually emerged as a transdisciplinary research field that actually focusing on how we can use information technology, data science, and the various forms of computational methods, like the method we just saw that Henrik have been applying, and we also have seen that Sita have been applying in her research. And all of these things will help us through the green energy transition of the energy sector. And what we want to try to achieve with all of this is also, as we have seen in many of the talks during the last 2 days, we want to increase the efficiency of either the electricity grid, or we want to increase the efficiency of the district heating grid. And we also want to make them more sustainable through the integration of renewable energy. And also, at the end of the day, we want to make them more resilient. So it's actually very short to show here. That is the whole integration from the large production side over the transmission grid, our distribution grids, and into the consumption side. And on the consumption side, we typically have the domestic prosumers, we have the commercials, and then we have all these aggregators that is aggregating the consumption here and offered it maybe as flexibility into the distribution grid. So this links very nicely to the model proposed by Dr. Watson in his book, where you actually have this simplified version of the information system, where you have the energy networks, like the district heating, the electricity grid. You have the sensor networks, that is basically the infrastructure on top of it, that feeds into an information system that help us to control this integration across. Yes. So it leads, when we successfully make this integration of the energy infrastructure, it actually allows us to use all these big data and IoT computational methods to implement a lot of things, like we can have better forecasting on the generation side, we can have improved forecasting here on the demand side, we can try to do some efficient design rights management, and we can do a lot of work on failure prediction and prevention or predictive maintenance based on all the data that we collect through here. So this is also some of the things that we have been working with over the years in a number of projects or the fields we work with. I'll not go into this, there's a more description of it on our webpage, but the thing is here, by working in all of these different domains and doing a number of projects over the year, have helped to develop the ideas, what is it that is needed in an education by doing? What are all the methods from the different disciplines that we need to move into a transdisciplinary education in order to make sure that the candidates we educate will be able to, for instance, optimize the climate in greenhouses, to integrate greenhouses with the electricity markets, optimizing the energy efficiencies in huge iron foundries, and integrate the electricity side, charging of the EVs, for instance, in distribution grid, and improve the energy efficiencies of building. So all of these projects we have been doing over the last 10 years have actually been the background for trying to make an educational program. So, but anytime before you do a program, you also need to make sure that it doesn't exist already, right? If it's already there, you don't need to make it. So I also have been going through all of the existing programs that exist and see what it covers. And when I looked at all of these programs, I realized that there's not really any program that focusing on the energy informatics field. I mean, the integration that Grace also mentioned through the different disciplines, both from the more informatics, data science, computer science part, over to the power, electrical, electronic, mechanical engineering, creating this bridge. So there's basically this, what I call here, the educational gap. People who are, what you can say, in both domains. I mean, people who are really much in the more traditional energy disciplines, and people who are more also in the digital disciplines. But of course, you know, we cannot expect people to learn everything. This is also the great challenge when you want to make an interdisciplinary education or have a field, is we cannot learn everything. We learn certain parts from many disciplines. So it's just trying to identify these parts and put it into an educational program that really becomes the big challenge. So in order to do that, I did a further analysis and tried to think about what are all the dimensions from the energy ecosystems that are relevant in such an education. We need to know something about the climate, the environment, because if you look at the solutions you develop, they are not the same. I mean, there's a big difference whether we are doing something for Denmark, right, or Scandinavia, it's heating. Now we're in Brazil, it's cooling, right? So the regional climate really influence on how we think. Social culture also influence on what solutions we can be building. Of course, technology, but I would almost say technology is the most simple thing here in the whole picture, because, I mean, we are so far with engineering, but we need to put it into the context of the other things. And the economy And of course, the policy and regulations is very regulated, the environment in which you have to engineer your solutions, or are there less regulations? So basically, I try to look in all of these different dimensions and then see what should I extract from it to put into a full program. So I ended up with a program that we have here. And this program is, of course, also very influenced about the framework in which I have to define it, which is the Danish framework. So there are some elements, of course, that are given by the structure of how a master education have to look in Denmark. So what is the most interesting thing to look at here is actually the other elements here in black, actually the courses. So the way it had been organized is that starting out with, and one thing, for this master, the idea is to build upon a number of bachelor degrees. It means that you can come with a bachelor degree in mechanical engineering, electrical engineering, power engineering. You can come with it from software engineering, data science. So actually it comes from different directions. And then you would ask me, Bo, how do you fit all of that into one master? Well, then we have a trick that we have something over here that we call semi-elective, and that's basically where you teach people some of the necessary skills that they don't have with them from their past. So we also call this sometimes, matching. I mean, the people's background with what are the requirements for following the other courses. So we have basically started out with having a course in energy ecosystems that gives people an overview of the whole ecosystem around the energy transformation. We also give people training in energy data management. We have some presentation over the last few days where it also shows, how important it is that you can manage your data, because otherwise you cannot really do anything if you don't have managed your data. And of course, the integration with the energy markets and the policy, because the energy markets actually defines what kind of technical solutions we can make. It doesn't help us to make a technical solution that doesn't match the market in the region where we want to apply it. Then we have put in course on smart grid, a very traditional course that covers the aspect of having smart grids and smart grid connected to main grid. We have looked into actually energy system data analysis and the method that are necessary for that. And then a course on the whole digital infrastructure, basically how you make sure you can connect and collect the data in the cyber physical system and bring it all up such that you can use it for making your high level control systems. And furthermore, on the same semester, we have courses here that goes into the renewable energy and storage technologies, and an aspect that I often think is ignored in too many programs on the energy systems is cybersecurity. I mean, it's very difficult to imagine that we can have an infrastructure on top of the energy infrastructure if we don't address the cybersecurity and cybersecurity by design. Because if you take out the digital infrastructure, right, then basically we have no energy any longer. So in that way, we would be very vulnerable. And then finally, on this semester, a demand side management course and energy efficiency course. So that is what we have on the second. And the third semester, which is the last semester where we actually have course activities, we look into this whole multimodal energy systems and also look into sector coupling, since that's something we are going to see everywhere in order to make this transition possible, is actually to see how we do better sector coupling a part of the electrification. And then finally, we have these two courses on artificial intelligence in the energy system. And we have another course that is mandatory in the Danish regulation for master degrees, is that we need to have something about innovation. But I also think it's a very good idea to teach our engineer students more about entrepreneurship and innovation in order to have more startups also that can help in the green energy transition, or maybe to try to change the mindset in this very conservative sector that the energy sector actually is. So, I mean, if our engineers are more innovative, it might also help to speed up the whole transition. So this is basically what it looked like at the moment, and we have it in the pipeline. So we hope that we would be able to welcome students in 2025. So, yes, that was all. I think I can have one question, if anyone have one. Otherwise, I can take questions in the coffee break.
Yes, if anyone have questions, of course, one thing is I know majority of us and all of us get our PhD already, or in the process of getting PhD. And yes.
Just out of curiosity, like if you create a new program like this one, do you have to hire new teachers? How does it work? Like if approved, then you hire, let's say, 3, 4 more people to teach? Or?
Yes, I will have to hire more people. And then also another thing we have been working on over the last years is also to, what you can say, grow the next generation of people who are interdisciplinary, such that we have someone out of the box that have the profile here. Because when we hire people for a program like this, people must be ready to change. I mean, I cannot hire somebody who really want to stay on a classical part of his discipline. I mean, I need to hire someone who will go into this whole mindset of saying, yes, I have to work in an interdisciplinary way. I need to change maybe what I'm doing to be more holistic. So it also requires people who think, okay, this will be exciting, and take the risk maybe of moving a little bit away from what they have been classically been doing.
Good.
Congratulations for the presentation. We are also here at the moment discussing how to modernize our curriculum to include all these aspects related to energy transition, but at the same time there is a conflict with the traditional knowledge for the electrical engineering. So, in our case, we have a very conservative curriculum, so our students, they have to learn how transformers work and how to model transformers and electrical machinery and distribution lines, transmission lines, and substations, all this kind of subject. My question is how to balance the old knowledge with the new knowledge.
Yes, that's very difficult. And sometimes, I mean, sometimes you should do something new and then keep the traditional in the traditional way. Because there's always in a university, between the different departments and group who participate in an education, there's always a lot of own interest in maintaining certain courses in the curriculum, because it might lead to master students and it might lead to PhD students for what you are in particular interested in. So change can be very difficult to implement in that way. So either it really have to come top down or grow from the bottom. People who agree now we do the change. I've tried that in a few programs. That's actually why I did the program in software engineering, a 5-year program I designed bottom up, because we took it out of our other program in computer engineering that then became robotics, pure robotics, and then I created software at the other side, because that solves this problem of interest. But when you go over and do something like this, and you really need to have this concept from software engineering about minimal and complete, because you really need to learn the minimal knowledge you need to get the job done. And that is where you have the conflict you just described with somebody say, oh no, you need to learn all of this. I mean, you cannot only learn this part, you need to learn it all. We try to say here, you only need to learn this little part, and then you know what else you might need to learn later on if you go more in one direction or another direction.